So good morning, everyone, or afternoon or evening, as the case may be. So in this segment, we're going to talk about how to systematically name these chemical compounds that you have in previous videos learned how to write. You've learned how to write the formulas, a balanced chemical formula for an ionic compound. Now we need to have a way to name that compound and name it not just using swear words that people use in chemistry, but using a systematic way to name a compound. And that's really important because just as though scientists use SI units as a common system of ways to express measurements, there needs to be a common way to name a molecule or a compound so scientists know what they are talking about and they have a shared understanding. So, there are rules for how compounds are named. And if you know the rules, then you can determine a compound's name and vice versa. And of course, there are some rules that have exceptions. We'll touch on a few of them in Intro Chem. If you go on in chemistry, you'll learn some more exceptions. But by and large, the compounds that we name in this course are going to follow this flowchart. And I really like this flowchart from your text. I encourage you to have it in front of you with quizzes and exams. And I like it because it organizes compounds in terms of three categories. One's at the top here. So when you are presented with a molecule that you need to name, once you determine which category that molecule falls into, then you can use the rules associated with that category to name it. So the three categories of molecules that we're going to name in this class are things that are ionic. So those are species that have a metal and a nonmetal. Molecules that are molecular or just have nonmetals. And then the third category that we'll use in this class will be acids. And in this course, anything that is an acid has a hydrogen at the beginning of it and one or more nonmetals. Okay. So we'll talk about acids at the end of this nomenclature series of videos. What we're going to start with are compounds that are ionic, things that are metal and nonmetal. And we're going to talk first about ionic compounds that are binary. Binary just means that it has two different elements, the metal and the nonmetal. When you are presented with a molecule that is binary ionic, you name the cation or the metal first using the name from the periodic table. So for example, Na would be sodium, Mg magnesium. And then the anion or the nonmetal, the second species in the molecule, is named as its name given on the periodic table, but you drop the ending, the INE ending, and add "ide." So for NaCl, it's sodium chloride, not chlorine. The INE gets dropped and replaced with "ide." So it's sodium chloride. Magnesium fluoride. So if I was to ask you to name this species SRBr2, you would have to look at that species and say, oh, it's binary. There's only two different elements. And it's ionic because I see a metal and a nonmetal. The metal being strontium. And so I name that cation first, strontium. And then the anion is bromine, but you drop the ending for INE to get I. So strontium bromide. And I'm not going to be picky on capitalization. Okay, so strontium bromide is perfect. Okay. So that's naming binary ionic compounds. Now, there are some binary ionic compounds that have a metal associated with them that can form more than one charge. Okay. In the next slide, I'll give you the list of those metals that can form more than one charge. But let's talk in this slide on how to name those kinds of molecules or those kinds of binary ionic compounds. If you have a binary ionic compound with a metal that can form more than one charge, then the way that you name that molecule is you still name the cation, same way as you did with the regular binary ionic compounds. You name the anion portion of the molecule the same way, but what's different is what's in between. And what's in between the cation and the anion are parentheses. And then you put the charge of the cation in Roman numerals. That tells the scientist or whoever is looking at the name of the compound what the charge of that metal is. And that's important to do with these particular metals that can form more than one charge, because we need to be able to know how to properly write the molecular formula. So looking at this species, CuBr2, how did I know? I know it's copper and I know it's bromide, but how did I know to put 2 here? How did I know that copper was a +2? So here is where knowing the charges of the monoatomics are going to be really important. So when we talked about how to write balanced chemical formulas, we said that the charges in that molecule had to be equal to 0. So bromine is in group 7, and we said bromine likes to be a -1 charge when it is in an ionic compound. There's 2 of them, right? Because of that subscript 2. So that means that portion of the molecule, Br2, has an overall charge of -2. So that Br2 has an overall charge of -2. So for the charge of my overall molecule to equal 0, because I want the charges in my ionic compounds to be 0, for the overall charge to be 0, my copper, my Cu, must be a +2. Because if my Cu is a +2, that cancels out with the -2 to give me 0. And since my copper is a +2, when I write the name of that species, I need to put a Roman numeral 2. So copper 2 bromide. So this naming system that we use for only some binary ionic compounds that have particular metals, that's called the stock naming system. So that stock naming system is shown here with the metals that can form more than one cation. So these are the ones that you need to be familiar with, that when you see them in an ionic compound, a bell needs to go off that says, oh, that's a metal that can form more than one charge. And therefore, when I name it, I have to use the naming method that shows the charge in parentheses. So that naming system with the charge in parentheses, that's called the stock naming system. And that's actually the naming system that is most popular, most common with these metals. You may also see in other textbooks, and actually in some pharmaceutical literature, you're going on into the medical field, you may see this older classical name that's given to these metals when they're in an ionic compound. So you do need to be familiar with and be able to use both the stock and this older naming system when naming binary ionic compounds with these metals. And so I've listed, this is a really handy chart, this chart lists not only the stock naming system, but the older classical name for those metals. And there's a little bit of a pattern here. You can maybe notice that just within a series, the ion that has the smaller positive charge always ends in us, and the ion that has the larger positive charge always ends in ic. So that can help you remember that. But you'll be able to use this with quizzes and exams. So I'm going to stop the video here. and we'll start it up again in the next little vignette. I would encourage you to try these examples on your own. We'll go over the answers in the next video, but these are species ionic compounds that have a metal that can have more than one charge. So I would practice naming them using both the stock and classical naming system. So I would try that on your own and then come back, and then we will go over the answers to these questions.